We're going to continue to practice factoring like we saw yesterday, but we are going to introduce a special product pattern called difference of two squares, which we can just shorten and call dots. So we are solving quadratics by factoring, which we saw yesterday. You again want to write it in standard form. That's that ax squared plus bx plus c equals 0. And then we use the reverse distributive property to break it down into its factors, which is our two sets of parentheses. We set each set of parentheses equal to 0 and solve for the variable. So nothing is changing from yesterday. We're going to see some problems in the notes today that look exactly like the problems we saw yesterday, in addition to this new difference of two squares pattern. So difference of two squares pattern in general, and I'll put it up the top here. If you have a perfect square minus a perfect square, it is always going to factor into the same pattern. It'll factor into two sets of parentheses, and essentially it's the square root of each term. So the square root of x squared is x, the square root of y squared is y, and then one is positive and one is negative. And the reason that this works is because if we were to distribute here, this is your x squared, you get a minus xy and a plus xy that cancel each other out, and then a minus y squared. Just note that there is not a pattern for the sum of two squares. Sum of two squares does not factor. And we'll learn about what to do with the sum of two squares in the next section. So taking a look at this example here, you have a perfect square minus a perfect square. So this will factor into two sets of parentheses. Again, it's the square root of each term. So the square root of x squared is x, because x times x gives us x squared. The square root of 9 is 3, because 3 times 3 gives us 9. And then again, one's positive, one's negative, because then our outside and inside terms cancel. So we have an x plus 3 equals 0. We have an x minus 3 equals 0. This will give us x equals negative 3 and x equals positive 3. One thing to make note of is that the difference of two squares, these are always going to have only two terms. So you've got 1, 2 terms, whereas the standard form had 3 terms. So it's not that if it has 2 terms, it's definitely a difference of two squares, but if you only have 2 terms, this is something to look for. It might be this, or it could potentially not factor, or it could be something different, but it's definitely something worth checking. So here's another example. We've got x squared equals 36. And so one thing you could do here is that we could solve using square roots like we did last week. So we could take the square root of both sides of the equation, and the square root of 36 is positive or negative 6. So this is one way to solve. We also can solve by factoring. If I set this equal to 0, I have x squared minus 36 equals 0. This is a perfect square minus a perfect square. So it's that dots pattern. So x times x, 6 times 6, one positive, one negative. And then when I set those parentheses equal to 0, I get x equals negative 6 and x equals positive 6, which is the same thing that you get when solving taking the square root, which actually in this case, this is probably your ideal method because it's much shorter, but just recognize that it's also a difference of two squares pattern. Here's another one. So maybe we would solve this using square roots like we saw in the last section. So maybe I would move this x squared over to the other side. I probably wouldn't move the x squared. I'd probably move the 100 to keep that x squared positive. So let's go ahead and erase that. Okay, so I would move the 100 to the other side, and I would say 100 equals x squared, and then I would take the square root of both sides. Square root of 100 is plus or minus 10, so I can get the solution that way. Or maybe I recognize this as a perfect square minus a perfect square, and I said, okay, that's a dots pattern. X times x for the x squared, 10 times 10 for the 100, one positive, one negative. So this would be x plus 10 equals 0, x minus 10 equals 0. You get negative 10 and positive 10 for your solutions. So again, just another way to get the same answer. This one maybe looks a little trickier because it's not a 1x squared. But this 9 Meant to put an arrow there, not a crossing out. That 9 is a perfect square. This is really 3x times 3x. 25 is 5 times 5. So we can do 3x plus 5, 3x minus 5 equals 0. So we're okay if it's not a 1x squared as long as it's a perfect square out front. We'll learn about what to do if it's not, or if we don't have this dots pattern in the next couple of days. Here, when you go to solve, it's a little bit more complicated than what we just saw because you're going to have to solve a two-step equation. So here you're going to subtract 5 and then divide by 3. So you get x equals negative 5/3. Here you're going to add 5 to get 3x equals 5, and then divide by 3 to get x equals 5/3. This, if you notice, has 1, 2, 3 terms, so this is not difference of two squares. Remember that I had said earlier in the period that if it's difference of two squares, there's only going to be 2 terms. So we've got 3 terms. This is standard form. This will factor into the 2 sets of parentheses like we saw yesterday. So x squared is x times x. Then remember, we need to figure out how to get 12 so that our outside and inside terms will combine to give us 7. So we've got 2 and 6, we've got 3 and 4, and we've got 1 and 12. It's not going to be the 2 and 6, because if I put a 2 and a 6 in, that would give me 2x and 6x, which would give me 8. Or if I subtracted 4, but not the 7, if I do 3 and 4, my outside terms here are 4x. My inside terms are 3x. So if they're both negative, those are going to combine to give me that negative 7x. So we've got x minus 3 equals 0. X minus 4 equals 0. Over here, add the 3. We get x equals 3. Over here, add the 4. We get x equals 4. Here's another one, 1, 2, 3 terms. So this is not difference of two squares. So we need to set it equal to 0. So I'm going to move that 30 over. So x squared minus 7x minus 30 equals 0. So I've got x times x for my x squared. And then for the 30, I need to think about, okay, maybe 3 times 10, maybe 6 times 5, maybe 1 times 30. I need to figure out what pairing is going to get me that negative 7 from my outside and inside terms. 10 and 3 will do that because then I have a 10x and a 3x. I have a negative 10 and a positive 3 that will add to give me negative 7. So x minus 10 equals 0, x plus 3 equals 0. Add 10. Subtract 3. And we get x equals 10 and x equals negative 3. So your assignment for homework tonight is factoring worksheet 2. Be on the lookout for difference of two squares problems.